Hey, thank you, JC. Also, thank you for all of our panelists that flew and drove all the way here in Fort Santiago. And Rory, thank you also, Camiel, Garrett, and Mauro for the very short notice just this morning. And also Garrett from yesterday, because we had sort of problems because for the rest of our panels of the coronavirus. And yeah, the main goal of this panel is actually inform architecture students, architecture professionals, architects, what technology is capable of. Because I think we're not really informed of what is the full capability of the technology to our industry. So as a new decade awaits to unfold, the 2020 year, new research and technologies are emerging. These technological breakthroughs help shape the architecture of any period. My first question for the panel is, entering the data-driven design world, what could be AI's role with architecture? I think Camiel can be the first one to answer this. I'm giving you the pressure.
So with 2 years ago, we start testing a digital blue foam where we harvest data online in a web-based environment and use that data to generate building design, focusing on the early stages. As the name is giving you, blue foam is focusing on the early stage massing model, like you used to do in foam studies and massing studies of just foam and how you cut foam and how you make a proportional building. But now we're bringing that online and using data to inform that process and inform that massing. So this is looking at data of where the sun is rising, how much rain is coming, where the wind is coming from. We look at infrastructure nodes like the metro, the train, the buses, walkability. It looks at commercial programs and other programs around the site to help you predict or maybe suggest what you could do at your particular building. So we very much focus on data and harvesting data and collecting data and using that data then to inform the massing. There are sort of a lot of AI paths to take from that and using other types of data as well. But I think for us right now, we're really focusing on the generative design part of that data. So creating an even field and a huge population of options and variety that we can then test in terms of outcomes of GFA, facade, volumes, green ratios, just to name a couple of things. So.
Do you have something to share, Mr. Mauro?
Well, thank you, first of all, for inviting me in this session. I think that I will repeat somehow something that I said yesterday about the relationship between sustainability and technology. Because I have the sensation that in the last years, since, as he was saying, we have a lot of data, a lot of clouds of data from every discipline. Every time we speak about sustainability, it seems that there is a prevalence of the technology over the shape, over the typology. And this is not so advisable, so fruitful, in my opinion, because as architects, we should always take into account how the shape of the building, how its morphology is contributing to this sustainability. This is what normally is called sustainability by design, the shape of the sustainability. And so if I can forecast a possible line of research for the future, is to study how the traditional technologies, the former technologies, the building that were built without architects, architecture without architects in the past, how these whole technologies contributed to the development of efficient buildings that could work already as a sustainable building, and then you can use the latest technologies in order to improve, in order to augment the performances of the building. So this is, in my opinion, one of the most interesting challenges for our discipline. And I'm doing a research on this, and not just me, of course, a lot of people around the world. And I think that finally, what I hope is that we should give up to speak about sustainability as a singular word, and we should start to speak about sustainabilities, different kind of sustainability according to the relevant characters of the local architecture and the local conditions.
Thank you. Sorry, Mr. Garrett, you're gonna share something.
Yeah, actually, I was going to expand on that. So what we do is we do a lot of energy simulation work, right? Internally, we do a lot of energy modeling, and year in and year out, there's always new programs that come in. You know, whether they can start to take into account the sun, the structure, and sometimes even now you can take into account how the actual construction is, right? Like how thermal massing works, how energy is transferred between materials. So you can even select these materials. So as we evolve, right, like technology is evolving with us, and design, I feel like, also follows it. And I think you make a really good point in that we shouldn't let technology dictate design, but rather use technology to inform design.
Yes.
And that's how we've seen it really work and work hard. You know?
It's not really my field, but one of the most exciting things I've engaged with recently with a developer who has a large portfolio of buildings in Hong Kong, actually. It was around the topic of digital twin. And it's basically where you generate a digital model of your building or of your assets. And your assets are delivering that model data, live data, so you protect. Getting your hands on other people's data is quite difficult, actually. But your own data is very useful. And what's very exciting about the digital twin is that once you have enough data, you can then accelerate a mirror image of your building into the future. And you can use machine learning and artificial intelligence to study and understand your building and how it will perform say, in 20, 30, 40, 50 years' time. That is the idea. It's still very much in the early stages in the built environment, in buildings, but it's an area we're looking at. But that will revolutionize the way we design buildings and think about buildings. And we have to get away from the, if you like, from the seeing a project as having a start and an end. We are going to see buildings in the future. We're not going to do more new build. We're going to do less and less new build, and we are going to do more and more refurbishment, repurposing, and reusing of property. And AI, digital twins, etc., are going to be part of that, and we're going to see truly lifetime use and understanding of buildings because of technology.
Thank you, Mr. Rory. I just want to follow up with the points of Mr. Mauro and Mr. Garrett, that the building can actually be a low-tech and high-tech at the same time. So can we expound, like, where's the limitation or the line between like a medium-tech design building? I think that's the most, or the way that we can create like a better design, like a mixture of low-tech and high-tech.
You know what comes to my mind is we've heard of, say, net zero energy buildings, for example. Nowadays, there's a formal definition on net zero buildings, but back then, maybe 5 years ago, when we were working on a net zero building, we were thinking, what does this look like? And is it high tech, or is it medium tech, and is it low tech? back then, we really thought that was high tech. So on this specific project that I'm referencing, it's a net zero energy building with all of the latest and greatest technology in it, and it works. Coming back home to the Philippines and starting to look at what's possible here because of the environment, right? You can use this technology, but you don't even really need to go high tech here, at least with like a climate region, that this low tech works. And you can still use technology to simulate, to model, to ensure that there's comfort, right, around it. But in terms of, just pushing technology into a building, you don't need to do that in certain climates anyways.
Well, I think that maybe there is a missing point in this reasoning, because we are speaking about high technology, low technology, sustainability, the building, but we are only looking at the architects and the buildings. So we are only looking at architects and engineers. We are looking at ourselves. There is another important part of the sustainability, which are the users. And I think that one of the most important things that architects and engineers must do in order to obtain a real sustainability of the buildings is to teach, to educate the people how to use correctly a building in terms of sustainability. Because I can assure you that in my life, my professional life, I saw so many smart buildings, very well designed, with very good equipment and so on, that were completely ruined by the everyday use of the people. Because, for instance, they had a system of internal ventilation. They opened the doors, so the internal ventilation was completely upset, and so on. I don't think that the numbers are so important. The numbers are important, okay, because we rely on the numbers. But what is very important is not to extremize the performance of the building. In Italy, that NZEB stands for Net Zero Energy Building, which is a building that can be detached by the network on the distribution. But in Italy, we have a very special regulation, and NZEB in Italy stands for Nearly Zero Energy Building. It is true. It is written in the laws, which means that we are attempting to obtain not a completely independent building. We are trying to reduce the amount of energy that the building consume. We try to increase the production of energy that the building produce. But the most important thing is to educate the people of how to use the building in this sense, in my opinion.
Yeah, the term I like is appropriate technology. Yeah. And the appropriate technology movement, I think it's Patrick Schumacher, not the one we all know and love, but he was Swiss, actually, I think, originally. But the whole concept of appropriate technology, that movement, I think it's from the 60s, 70s. If you haven't looked into it or don't understand it, it's well worth looking up. In my own personal practice, I have seen how technology can take vernacular architecture of the simplest technologies and modify them to enhance their performance incredibly so. And I'll be talking about that tomorrow. There's a plug for my talk tomorrow. And I've seen it again and again. And the example I love talking about is we have a school project in Ladakh in northern India, which uses trum wall to heat the residences of the students at night. And that, it's very cold, but there's very high solar intensity. And we basically put the walls behind glass. During the day, that wall heats up, and at night it releases energy into the rooms, keeping the children at about 16 degrees, which is good, when it's minus 20, minus 30 outside. And that's purely, adding zero energy. That was achieved using the most high-powered software we had at that time, which we were using on triple glazed city offices in the City of London. It was cutting edge technology in terms of software, but we were able to model mud, brick, sheep's wool, silk parachutes, and other materials that were available to us on this project, and achieve something that has exceptional performance. So it's a nice marriage of the two.
Yeah, I'd love to learn more about that project, and because it's almost a low-tech solution with a high-tech start, right? And I think also what's really important that we look at what's comfortable, right, as a level. You're going to put your aircon at 18 degrees or at 25, and it makes obviously a massive difference, and it's very easy to do, right? So those are very easy steps to take on quite early on. You don't need any calculation, and it comes very simply, right? And I think also what I wanted to add on, if you have a high-tech start, you can have a low-tech resolution, like just orientation can do tremendous work for your environmental solution later on, right? It can help you a lot in that sense, and I think that's something that is often completely forgotten in projects. So yeah, I just wanted to point that out as well.
Thank you. We're been discussing to like how to create or integrate technology to new designs. But what do you think? What we can solve with today's global problems, like from the China's building up this hospital for 10 days. So what are the problems we can solve with today's technology?
It is a huge question, because I don't know if architects can solve so many problems. Maybe we can solve small problems, but a high number of small problems maybe can make a big solution. Well, I think that many of the problems of the world cannot be solved with the technology, but maybe with a wise planning of the cities. And the planning and the urban design maybe can be nurtured, can be fed with technology, because you can use the modern instruments of calculation, GIS systems, and so on, in order to retrieve, to collect data, and to use this data in order to be more efficient in the planning. But I think that there are different scales of the problem, and the problem that the technology of architecture can solve are very local problems. The global problems maybe can be solved with other
with the collection
with other techniques.
Yes.
Yes, maybe.
You're going to add something.
Sorry, I just want to jump in. You say local versus global, but local is global.
Yeah. No, just in terms of, yes, you're right. Finally, I was just speaking in terms of sizes, not in terms of relationship with the artist. Just in terms of size.
Yeah.
I could talk about. It's not really the buildings or architecture, but there's a lot of talking about the promise of technology, and we have to be very careful not to overplay it. And so much of it is just far too sophisticated for the real issues we have to solve. But one of the real issues we do have to solve, and this is a topic here as it is in Ireland, is transportation and managing and charging. I think the future is going to be driven by charging people appropriately for using energy. And so one of the things that technology is allowing, and putting the personal privacy to one side, because anybody who's carried a phone around with them today has already given up that privacy. So it's a moot point. But just for example, one of the things that's very close to being instigated is charging cars on for kilometres of road used, and time, so a formula between time and distance on roads. And that's only possible because of technology. And it's going to provide lots of data. It's also going to drive change in behaviour of users. And we know in Ireland that change in behaviour is not actually very price sensitive. A lot of people think you need big changes in cost to drive change, but we demonstrated that that's not the case. I'll come back to that in a moment. But transport, the way transport is planned, provided, and with, of course, AI and machine learning with driverless cars, et cetera, we're going to see a revolution there, and that is going to have a massive impact on buildings and the built environment and planning. There's no doubt about that. That's real. That will happen. And whether it's a developed country or a developing situation, it's still appropriate to apply that technology. The example of price sensitivity is when Ireland, I think, was the first country in the world to introduce a ban on free plastic bags. And when we did that, it meant that when you were leaving a shop, you had to pay for the plastic bag, but you only had to pay 1 penny. It was nothing, but you only had to pay 1 penny. But it totally, overnight, changed the demand of people for plastic bags by 90%. It dropped by 90% for a penny. So there are lots of things. Human behavior is very important to understand as well, and the way it responds to change.
Yeah, thank you. Actually, I just want to ask on this randomly on. It's a really different topic on what do you think about the future of space architecture, of what are the possibilities of space in architecture, or designing architecture in space, or what are the benefits if we go to space and create or for example take over Mars or something. It's just a theoretical question.
From where I'm sitting and what I think and what I sort of observe is that densification is just a huge topic. I think that transport is definitely going to have a massive influence on...
Since Rory also mentioned transportation.
Yeah, and I think with that data is, for me, probably the third thing on what we'll have in the next few years ahead of us, where we need to work with and adapt to and thoroughly think through and what we're going to do with that and how we're going to attack it and how we're going to handle that. And I think it's a very big question again, and really interesting, of course.
To talk to the same. As Rory mentioned before, we were talking in the email that you were asking if what you could present in your talk tomorrow. Also, this is a plug for your talk. So you also mentioned you mentioned that what can wooden high-rise buildings, the future of. Can you tell us something about it?
There's less is more, and the use of engineered timber in the built environment is going to explode in the coming decades, and I think we could easily see. Higher. Right, I'll say that again. I think we're going to see an explosion in the use of engineered timber in the built environment, and it's for a number of reasons. As I said earlier, we're going to see less and less new build happen in the world. We're going to see more and more repurposing of existing stock. And the new build, the concrete and steel sit alongside petrocarbon, oil, gas as almost dirty words now. And that's not it's not a boutique timber is no longer a boutique item that we can talk about. It's actually very real. The technology is now there to take very basic softwood timbers from 5-10 year cycle plantations and turn them into incredibly useful structural building, cladding, and other elements in the built environment. And the more we use in a way, the more carbon we're locking up permanently. And so it's very positive. Technically, everything is in place. For a country like the Philippines, where you have the ability clearly to have forests and harvest forests, it would help grow an indigenous industry around the growing and then manufacturing of timber elements. And you can easily cut down on miles traveled, carbon, etc., etc. There's lots of reasons. The only things holding back timber, at the moment, the tallest buildings in the world are around between 20 and 30 stories in timber. Lots of people have drawn 50, 60 story timber towers, but they're not built yet. And it will be a hybrid system of timber using maybe some steel or some concrete to achieve high density and height. But it's, I'll be talking about that and issues around fire protection and energy tomorrow. Yeah.
With the what we've discussed as the main problem with timber construction will be the supply, and a lot of environmentalist architects saying that we don't have enough trees to build these buildings out of wood, out of timber.
Yeah, there are plenty. There may be countries that physically don't have the space, but there is land there available in most situations to have to grow timber and to harvest it in a cycle, rather than attacking a virgin forest or a well-established forest. So there, of course, in some places there won't be the supply. I think the biggest barrier now to timber is not supply; it's actually us. So it's our willingness, our clients' willingness, and our own personal choices. Timber is associated with the past. It's associated in a country like this with termites, etc. All of these things have been solved. You can now build structures out of timber, of engineered timber. You can build structures out of engineered bamboo. And I'll be talking about engineered bamboo probably tomorrow as well.
All right. That would be interesting.
So the biggest hurdle, I think, is ourselves and reluctance to give timber a chance.
I think it's the same. What Mr. Mauro was saying, that if you design a low-tech and high-tech building, or just a high-tech building, the main problem actually at the end is the users, or the misinformation of the users on how they're gonna use their buildings. So I think it's on us, or it's with us architects, that we should inform our users to how to properly use our designs, or how to make them properly use or utilize our design.
Yes, and more than this, maybe we could contribute to demolish some common ideas that maybe are not so correct. Because if you look, for instance, in the official narrative about the technologies of architecture, normally the concrete is associated with something bad, because the concrete cast is the responsible of the sprawl and all these bad things. And normally the wood is associated with an idea of good, of something which is good, because it's natural. Well, actually, I don't think that there is a good technology and a bad technology. Good and bad depends on how we use the technology. And in some cases, wood technology is the best choice, because it allows the construction dry construction site, and because it has a lot of advantages. In some cases, not. For instance, some years ago, I designed a building for my university, And that building had to be built very quickly because it was my university needed these classrooms very quickly. And the director of my university started asking me to design the building in wood. I started considering this possibility, but I immediately realized that we had supply problems, like you said, because it was very hard to obtain such an amount of wood to industrialize this process. And so I say to him, why are you asking me to build this building in wood? And he told me, because it is much sustainable, it is much recyclable. And I said, okay, but what do you mean with recycling? Because I don't think that recycling into architecture means that a building can be demolished very easily in order to reobtain the raw materials. Maybe recycling in architecture could be better seen as design a building the way it can be reused in different way, changing the program.
Not directly to another.
Yeah, and so this was finally at the end of my discussion, I decided to build this building in concrete because it was easier, it was cheaper, and it was very faster. But I designed it the way that it can be changed. It can be changed. Only removing some walls, some internal walls, and it can be transformed in a library, in some workshops, in some laboratories, and so on. So maybe we could contribute to educate the people also to these ideas. That the sustainability is always a balance between different forces, and technology is just one of these forces.
Sorry, I'm going to go ahead and contribute to this wood talk. So I worked in the Pacific Northwest for quite a while. And in the early 2000s, there was an infestation of pine beetles. These pine beetles killed a lot of the forest around. So as a result, there was a ton of wood available, right? Again, very different situation, probably anywhere else in the world. But there was a problem. The problem was in the places that we were practicing, the building code only allowed us up to 3 floors if it was timber. And so we were faced with this dilemma of having an abundance of this cheaper. And actually, maybe the crux of the matter is the embodied carbon, right, of concrete versus embodied carbon of wood, right? So concrete has a much higher embodied carbon. And that's really why the whole community doesn't really like concrete, so to say. But in that specific scenario, we had to contest the government, contest fire codes to enable us to build higher than 3 floors. And in fact, in BC, where I was working, we were referencing a lot of projects from Europe where they have already been constructing in wood like 12 stories, 15 stories, no problem, right? So it's using this, I don't know if it's old or it's new technology, but it's just using what was abundant to us to get to a point where it was the most sustainable solution. And it was also pushing the government, pushing regulations to the point where you could apply these solutions that you otherwise were only blocked because of the government.
Yeah, and it's that story is why I say it's about people, and that includes regulators and lawmakers as well. And it's interesting you give the example in the US, because maybe 10 or 15 years ago, the US was considered to be behind in timber technology and adaptation. They are now seen as world leaders. They have realized the benefit and the potential in timber and are now really set, world trendsetters in technologies. And one of the things that's happening in the States, of course, it's state by state. You have to change the regulation. So, but that is happening. And there's an organized timber industry across that's pan-state that is moving each state by state to bring their codes up to date with research, and so it's a very positive story.
I just want to continue also on your design of the university. I think it's super that the regulation is changing, but what if you could have designed the building at that time and instantly could have seen this is the volume of the structure that we roughly need, this is how much wood we could use, or this could be a combination of it, right? these tools are not available yet. And why are they not available? Why are we still doing all these things by hand? Right? You at the time you had to design university. Your professor wanted to do it in wood. You explored concrete.
Yeah.
But there was probably quite a while in between that process.
Something between.
Yes, that probably took quite a lot of time to figure that out. So what I'm trying to say is also like what we're discussing here is data, right? And I think in architecture, and I think data is informing ourselves better. And typically we're just drawing plans and we're drawing projects up. But to truly think about data and how that informs a project should be much earlier, right? This information should be at your fingertips,
Yes.
not a layer of a pen or the thickness of a line weight. It's not as important, right? But somehow we're stuck in that, right? Which is baffling me. But that's really something we're trying to tackle with Blue Foam, and we're hoping that people can sort of help us to address and help us to think with that, right? How we can use more data early on in the design process, right? If you have the knowledge of that you are allowed to build certain states in a different height in wood, it would allow you to make decisions much quicker in terms of what direction your project could be going and be more sustainable. But I think the problem that we all face is that our way of working is very isolated, right? How many of you work in a team, and how many of that is linked to the internet, and how much of that information is streaming into your drawing? Can anyone raise their hands? You see, that's a massive problem. There's so much information that we are not using, right? And I think that's something we really have to be aware of, and we should tackle together, right? And that's just something I wanted to highlight, because something we're trying to do, and also trying to embrace other people that think with us on this line.
I just want to follow up that notion with we should involve more technology or data in our designs before, not just the research on the history or typology or the weather, but maybe help or ask help from AI probably to shape a better form. So do you think AI could someday replace architects? Or maybe it's just a helping tool?
Never.
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 We agree to that.
I think AI can help with a lot of the dumb things, making schedules, setting up your drawings, setting up your layouts, cutting sections, all that stuff. I don't think AI will ever be able to replace intuition or interpretation. Right? I don't see that happening. It can make a lot of good decisions, but those decisions are taught to a system based on data. Right? And I have no idea how you would teach intuition to that typically an architect is very good at.
I would take a different tack on that. Technology, AI will replace architects. It will replace engineers in possibly 50, 60, 70% of what we do today.
Yeah.
And that's coming very fast.
I'm going to jump in. Sorry.
Huh?
But do you think that's on sort of the mundane things, or also like the real core, like what is culture, what is intuition, right? What is the meaning of a site? What is the meaning of a location?
You know, my experience in the built environment, you know, very early on I was exposed to high-end architecture and design ambition and competitions, and you could see clients investing in design. I see that declining rapidly. It's more and more commoditization and price. And when Google launch Architect 1.0, which will mean that you sign up to Google for your architecture and not go to Joe Bloggs down the road and sign them up for architecture, you're going to see an awful lot of clients are going to choose that. And it's in the same way that people in Ireland 40, 50 years ago, when they wanted a house, they went to their local supermarket and bought a book of bungalow designs and picked one out of it and gave it to the builder. So, you know, while we can be alarmed, don't be. things have constantly changed. But the rate of change and the power of machine learning and AI will overtake us. And as a firm, we believe that. It will overtake us as engineers and designers. And what we need to look forward to as well is what we do. What role do we play? And what do we do in a society where there will be less and less employment? Will there be, the positive outlook is that there will be new jobs and we'll be doing there'll be a lot more service industry, etc. We'll be doing a lot more of different things. We might be returning to farming more and more. There will still be things to do, and there will still be the role of intuition and brain and design and an eye for good detail and etc. But it is going to change dramatically. And you, as most of you are students, you're going to see what you think your career is today in 10 years' time will be unrecognizable. You have no idea what it's going to be like in 10 years' time. So just don't be afraid, but be prepared for change and embrace it. But just be aware there is a social contract and there is a social side to this that does need to be tackled.
I just want to respond to that because I think there's a big difference in AI of the overall architecture and splitting it up into different parts, like the intuition, but also the sort of more mundane things where a system that is pre-set up can respond to particular conditions, like the orientation in the wind, like the wind or the orientation in the sun, right? And from that you can develop a building. You can say I'm a GFA. You can generate a building in seconds. You can draw a building up in seconds. We can draw a building in seconds. It's easy. But to make a decision which one is better based on maybe a client's idea or a client's suggestion or discussion you've had with a client, that'll be extremely hard to code up. And I think that's a very important part of the interaction you have with your client and the building. Yes, you can let it run and it's all drawn out, but to make final decisions on that, I think is still based on architects. So I think it's important to understand the core part of architecture and what that is. It's maybe not doing layouts and schedules and all that stuff. That for sure will be gone.
I'll fire back at that, if I may. But when you open up your phone, the adverts that you see were selected for you, okay? And the very client you're talking about, who logs into Google 1.0 Architect, they will already have data on potentially all of the users of that future building, not just the client.
Yes.
And it will suggest designs.
Yes. Yeah. Yeah.
And it'll make a recommendation.
Yeah, but the client will pay. I think they'll make a decision.
So it's going to be very interesting.
Yes.
I'm okay.
Thank you.
Like in Formula One.
Where's the champagne?
Actually, I'll share another story, and I think this probably ties into what you were discussing, indicating that it's probably the stupid part or maybe the tiresome part of architecture that you probably want to farm off to these, let's say, robots or AI, right? But also touch into your point on how this is slowly taking over a lot of people's jobs. So this is maybe 5 years ago now. Or maybe 4. We had just started using Rhino. Rhino and specifically with Grasshopper. Rhino with Grasshopper is a very powerful tool. Similarly, I think sometimes, I know how to use Excel, for example, but there are some people out there who can really use Excel. Like, they're much better at it. And similarly, I was using Rhino with Grasshopper, and I met someone who was able to actually use Rhino with Grasshopper in a way, way more advanced way than I can. And so what we had the design, and the design was very intricate and called for wave patterns, right? And when we priced it out, the contractor said, this is very difficult and it's going to cost you X amount. It's too much. This guy says, well, I'm going to use Rhino and Grasshopper and make a parametric modeling and try to see where we land. Sure enough, this guy with his program was able to reduce this super intricate design into 12 pieces of ACP panels and was able to price it out. And it cost 1/4 how much it would have cost initially, right? So this is how crazy technology is like informing architectural practices. And this is probably one of the things that you were talking about, where it's not the design anymore. It's the harder part. It's the schedule writing. It's how to get it there, right?
The actual processing of your design, and that's something we've done a lot in the design studio. And it's critical to get crazy projects built, or projects that have a lot of articulation. Grasshopper is great for that, and Rhino is very helpful for sure. Yeah. Grasshopper has been going for I think 20 years already. It has developed tremendously. I think there are limitations and opportunities within Grasshopper that you have to really understand as a team and how you work. But as a tool, I think it's fantastic. Yeah.
All right. Actually, I just want to. I was kind of hearing some questions around here. I want to open the panel questions to the audience, if they want to. Do we have a mic going around? Questions for our panels.
Hello. So I'm Tracy Behar.
Hi, stand up. Introduce yourself.
I have a notebook
Hi.
on my
Yep.
lap. Sorry.
Yeah, sure.
So I wanted to ask, with your short stay here in the Philippines, what do you think, since I've heard it several times, even yesterday, that cities will be the future of where everyone will be. What will happen to the provinces? What will happen when technologies goes also beyond the cities, when it goes to the rural areas? Will our cultural identity, how will there be a compromise of maintaining that cultural identity but keeping it forward with the technology that would be introduced?
Okay, I think it's a really great question. What we know from McKinsey and Deloitte studies is that AEC and agriculture are the two least industries that have been digitized. My view would be that definitely with digitize and modernize, also in the need for food. I'm sure Rory, looking at me, has a good take on this.
I'm not quite sure what I'm supposed to say, but the role of land is going to, with global population going the way it is, land is going to remain very important. I think there will be, we're heading towards 70% urbanization. At some point, there has to be a tipping point where we have to make living outside of urban areas and in the countryside attractive to people. And I'm not sure there are good examples yet of where that's happened, maybe in small communities or whatever. But for sure, there has to be a revolution in the countryside, I would say. Interestingly, I think it's next week, there's a show by OMA opening in the Guggenheim in New York around the topic of the countryside. Rem decided 10 years ago that everybody was talking urban, so he should go in the other direction and talk to the farmers. So there might be a lot of interesting ideas in that, actually. I haven't had a preview or anything, but I think that's going to be very, very interesting show. So that opens next week. But absolutely, there has to be a change in rural situation. I don't know the situation here, but I certainly know in Ireland it is quite unattractive to live outside of the city. And we have to do something about that, very much so. But what it is, I don't know. And how is technology going to drive it? I think the access to high-speed internet will be a fundamental human right that will have to be provided to the countryside as equally as to urban areas, and through the ability to have access, that technologies will be brought into rural areas and will change life there, and it'll allow people to work from home as well. And lot of other things. I think it will have an impact, but I haven't thought about it too much.
Actually, to answer your question regarding the cultural aspect of the suburbs area, I think it depends also with what the program would be and how the architect's gonna design. I think it will be with us or our jobs to create or design and involve what culture of that suburbs. So, and also depending on the program. So if you just, like Rem, his research basically about factories, about mechanical, like 1% in that factory is just humans and then most of it are mechanical. So you don't need culture with those kind of designs, with those kinds of programs. So I think it depends with the program and the designers.
Hi, my name is Evita. And my question is, this has been an idea that I've actually been incubating in my mind. I'm just gonna take it down a notch about technology. Technology in the sense that it's, I'd like to call it biotechnology. I was just thinking that there were these giant trees in California. They call them sequoia. And the idea that I was crafting was maybe we could use these giant trees as the superstructure for certain multi-story buildings in a way that, we don't take them down or anything. They just form this very organic kind of architecture. I think that it's somewhat related to technology, just the same, on how you can use the kind of technology that's so much more advanced than what we have now, because it's nature. It's a different kind of technology. I just wanted to get your reaction or your insights on that kind of idea. It's more of like designing for the far future.
I think. What are your thoughts? It's really impossible. I think it's really difficult to live in those kind of situations because first, those trees grew up without us, without us touching them. So if we enter to that scenario, it will be like it will be a sort of a mess in the ecosystem that surrounds that area, especially in California. So I think I'm actually imagining the Avatar, if you're familiar with it, the blue people. So I think it's really a good story novel, like movie type theory.
Actually, there is an entire field of research and technology which is trying to develop new technologies that mimic the natural systems. The example that you cited, in my opinion, could be nice just for small experimentations. Actually, there are some examples of house trees, but I don't think actually that this could be a mass solution. Because I think that when technology is trying to mimic the natural processes, you always have to, if you want that your solution is going to be to solve some global problems, you always have to pass through an engineering process. And so I don't think that mimicking the nature means simply repurposing the natural systems like they are, or maybe reusing the natural systems like they are, but it always entails an engineering process that grabs the laws of the nature and use the laws of the nature in order to create something new. This is my opinion, what we should try to do in terms of the relationship between technology and nature.
Yes.
Sorry, I quite like the question actually because it reminds me of Nemo, right? There's a symbiosis with his environment and how the little fish lives, right? Is that how you imagine it?
Actually, I'm just going to add on. So the concept that Mauro talked about is called biomimicry, right? And there's a good book. I can't remember who wrote it, but it's called Biophilia. And it gives you certain more concrete examples of probably what you're thinking about on how biomimicry has affected architectural structures. For example, while building I worked on, we had like a huge windows in front, and we just put vines on them. So then during summer, when it was sunny outside, the vines would grow and would block the sun away, right? And then during winter, because they're vines, they would kind of go down and allow the sun to come back in. So very, very simple example of biomimicry. Yeah.
For instance, there are some good examples of engineerized nature, which are some sun reactors that contains algae, a particular species of algae that can produce both energy and maybe food in some cases. Maybe they can reduce the pollution in the air. And so this is a very good example of how a natural system can be grabbed, studied, and engineered in order to be transformed in something that can be spread globally and not just in a fancy building.
Yeah, I think it's we that's our last question for our audience, and with the weather coming in, I want to thank everyone, Mauro, Garrett, Camiel, Rory, for having this panel discussion with us, and I hope a lot of our audience will bring knowledge back to their practices. Thank you.
Thank you all for listening and sitting through the weather.
We have
Yes.
rain. Buzzer beater.
Okay, so thank you so much, guys, for joining us at the first panel discussion here at Shelter Dialogues of Anthology Architecture and Design Festival 2020. Just a gentle reminder to everyone to please find a shelter, even if you're in Shelter Dialogues. And also to our professional pass holders, don't forget to log out. Thank you. To our professional pass holders, don't forget to log out for your